Everything that we do starts with software. Everything we do starts with software. And everything we do is in service of all the software developers who are solving these really difficult algorithms. We are represented by $100 trillion of industry here. Well, we still have to guide the software. We have to create the algorithms such that the computer can go write software. And that algorithm is called deep learning. Now, you could have a computer that's 100 times faster or 20 times more energy efficient, cost 20 times less, and to be able to solve problems at a scale that nobody's ever imagined, such that we helped solve artificial intelligence. And we're now on our way to making enormous progress in automation of intelligence. And as you know, intelligence is foundational to every single industry. In the last 8 years, we improved performance per chip. Per one of these chips, we improved the performance of one of these chips by 1,000 times in the last 8 years.
So that means it can talk about a movie? Does it mean it can read Anna Karenina? What does it mean that it's so fast?
Well, first of all, it's probably read those things and probably read about the movies. And so if you wanted to ask it a question about those movies or a book, you say, read this book. Now let me talk to you about this book. And you can talk to it about just about anything.
Can it make it so that a product like the Vision Pro becomes a commercial product?
Well, first of all, I've enjoyed the Vision Pro, and I got to tell you, it's really fantastic. I really, really enjoy it. And they've done such a great job with it. The thing that's really great is when we connect Vision Pro with this world we call Omniverse, and it's running on these computers, we essentially create this digital world that's overlaid with the physical world. And Apple calls it spatial computing, and you feel like you're practically there. It's really quite amazing. Just as we use the technology, artificial intelligence, to understand a novel, we can use a similar technology to go understand the meaning of proteins, the meaning of life. Now, once we can understand the meaning of life and be able to use it in a computer, we could use that computer to simulate life such that we don't have to do as much of the screening in a wet lab. We could do a lot of the screening in a computer. That computer does it so fast, we could explore the chemical space that is so much larger, explore the target protein space so much larger and so much more quickly. Our architecture, on the one hand, could do artificial intelligence. It could do computer graphics, physics simulation, data processing, SQL data processing, which consumes a lot of energy, a lot of cost. For many customers, we reduce it by 95%, 20 times reduction in cost and energy used. So much so that Google's Dataproc is now accelerated by it. We announced a partnership yesterday with a great company, Databricks. They're going to accelerate their data processing. They're the large-scale data processing cloud company. They're going to accelerate their data processing on it. We're in the beginning of this AI ramp. We're going to make computers smarter so that they don't have to learn computer science to program a computer. The computer should just understand what we want and what we intend.
But we say, please help me build a factory that can make the best cars. It can do that?
It surely will help a lot. And the reason for that is because you give it a plan, you tell it what are the type of parts that you like to put into it. Eventually, this factory will be a robot that's orchestrating a bunch of manufacturing robots that are building cars that are going to be robotic. Is that we have to teach a robot how to be a productive robot. And you need data for that. We're in a world where in order to write a software for a computer, we use data or training examples, and the computer learns from the examples. You know, artificial intelligence is good at emulating us.
Okay.
And so it emulated how we read. And it emulates, in order to emulate how we read and finish sentences and summarize paragraphs, it had to understand what it read. And so in order to emulate us, it had to understand words. Well, ChatGPT is quite an amazing breakthrough. You know, the OpenAI engineers and scientists there.
But it's based on this!
Yeah, I'm very proud that NVIDIA's computers made it possible for ChatGPT to be possible, but their researchers did just unbelievable work. Here's what NVIDIA is: a market maker, not share taker.
Okay.
We create markets. Everything that
Right.
we do didn't exist before.
But then why are some people so scared of AI, so have public fear that this is going to, make them so they don't have a job? This is going to create jobs.
This is going to create jobs. It's going to make companies more productive. When companies are more productive, their earnings improve or their revenues go up. When that happens, they hire more people.
Well, that's
Yeah.
called an industrial revolution.
That's right.
That's what the loom was. That's
That's
what
right.
the steam engine
It
was.
made companies more productive, created more jobs, and made the economy larger.
Is there a CPU that should withstand it, or wouldn't we want everything? Don't we want this in our PC? I know we don't have it yet, but don't we want this ourselves in a consumer fashion, not just business to business, not just enterprise?
Absolutely, absolutely. Every device will run artificial intelligence software. The question is, are they small software or larger software or gigantic artificial intelligence
Well,
software?
I listen to you and I wonder, won't there be an arms race? We're not friendly with every country in the world. Won't other countries say, you know what, we have to create our own Blackwell and compete or else we'll be left behind because we shouldn't necessarily share what we have as a country?
The most important thing that countries have to do is to create their own intelligence.
Okay. Sovereign AI.
They have to do their own sovereign AI. And the reason for that is very simple. They have a lot of data that belongs to their country. It's their natural resource. It's of their people, of their language, of their culture,
So we want to
of their
encourage
history.
China to do this.
China's going to do their own anyways. But every single country should process the data of their culture and turn it into intelligence that their own society can use. Sweden's already doing this. India is working on doing this. Japan is working on doing this. I think every country should do their own and make sure that they own their own intelligence.
So there's no hegemony of the United States,
And
which
we-
would be terrible.
But most importantly, it's because the data belongs to the people. It's their national assets, their national resources. It could of course be combined and shared with everybody else. But we're happy to provide the hardware that helps everybody do that. But it's really important that all of the countries create their own sovereign AI. One of our computers, this is our latest generation, this is the chip that goes into it. This is the largest chip the world's ever seen. This is beyond the limits of physics. We had to invent some new technology to make it possible to do this.
How many
This
bits
is
are
208 billion transistors.
in that?
Gosh, it's even hard
that, what we're looking at.
in this little tiny part in the middle.
And what should that cost?
This will cost, $30,000, $40,000.
And how much did you spend to develop?
The very first one, the R&D budget of this generation is probably something like $10 billion.
10 billion, not million. 10 billion.
$10 billion,
And you
yeah.
deserve the right to be able to recoup that.
Well,
and you're doing it.
Well, we're going to do our very best job.